Okay, in this lecture I want to talk about what a destructor is. Now, like the constructor, it is a special member function, but in this case the destructor is invoked just before the object is destroyed, and it's useful for automated cleanup tasks, such as the deallocation of dynamic sub-objects. So the constructor is used to essentially initialize the state of your object, so in other words the member variables of your object. The destructor is meant for cleanup tasks. The destructor has the same name as the class as with the constructor, but the destructor is prefixed with the tilde symbol, which on my keyboard is right at the top of my tab and to the left of 1. I also have to press shift to access that. The destructor also does not return any values, so you should not specify a return type for the destructor. Now, the destructor also doesn't accept any arguments, unlike the constructor. So don't specify formal parameters for a destructor. It's basically invoked automatically just before the object is destroyed, right? So we don't pass it any arguments. Now, because the destructor does not accept arguments, it cannot be overloaded, and a class can only have one destructor. Here is an example of a destructor. You can see I use a class called entity. I'll be using this more and more as we go along, so we'll use these entity examples for more generalized, again, high-level examples, right? And what is an entity? Well, it's just a thing. A person can be an entity, for example. So instead of class person, we have class entity. And a person can have some attribute or member variable that stores the date of birth, whereas an entity on a higher level just has some member variable. It's just a high-level example. You can see this entity class has a constructor and a destructor. Both are declared and defined within the class body. You can see the constructor doesn't do anything in this case, it just has an empty body. And the destructor has a single statement in the body, a console output destructor invoked. Also notice that the destructor is prefixed with a tilde. The opening curly bracket doesn't have to be that way with the destructor. Again, the compiler doesn't care about white space. It's just this way because of space constraints. Let's talk about when a destructor will be invoked. At this point you should be able to think about that by yourself. But just as a summary, when a local object goes out of scope, just like a variable goes out of scope, that variable is destroyed, right? And the same thing happens with an object. When does that happen? Well, when a function returns, the local variables are destroyed. That includes the local objects. Again, you can treat an object like a variable. Basically the same thing, is just a custom variable, right? The same thing when a compound statement returns. So when a compound statement finishes execution and program execution moves to the parent statement, then of course the local variables or objects that were in that compound statement will be destroyed. And also when you have a dynamic object on the heap, again, if you remember, you create a dynamic object using the new operator. Now when you destroy that using the delete operator, then of course you will also go and invoke the destructor. Here's an example in the main function. You can see I have a compound statement or a code block within the body of the main function. I instantiate the entity class. I create two objects named entity1 and entity2 just for demonstration purposes. When that compound statement finishes execution and program execution moves back to the main function, then of course all of those local variables, in this case objects, will be destroyed. So entity1 and entity2 is destroyed, and the destructors for entity1 and entity2 will be called. Okay, then we create a dynamic object. We have a pointer to an entity called entity3, and I use new entity to create that dynamic object on the heap. Then I do delete entity3. When you do that, then of course the destructor is going to be called for that entity. Okay, here is the entity example. I have the entity class right here. In the public section I have the constructor, and just for demonstration we can go and initialize our members, our member variables. And then right here is where I have the destructor declared and defined. Now all I'm gonna do in the destructor is I print out destructor invoked, so console output destructor invoked. Then in the main function you can see I have this code block right here, and within that compound statement I go and instantiate entity, entity1 and entity2. When program execution reaches this closing curly bracket, we'll call the destructors for these two objects. Okay, then down here, just as we had in the slide, I go and create a pointer to an entity. I use new to actually create the object on the heap, and then I simply delete it again, so delete entity3, and that will also call the destructor. I'll build and run that, and you'll see that is what we get. Destructor invoked 3 times. Of course you can go and experiment with this. maybe step through the code, but this was just a high-level example to get the idea across of what a destructor is and when it will be invoked. Okay, I'll continue with this entity example, and in this section we'll talk about where destructors are really handy, and that is with regards to the deallocation of dynamic sub-objects. Now, I've talked about sub-objects briefly in the structs lesson. Now let's say, for example, you have a class called playerStats, and you have a struct member, and let's call it location, and that might be a vector 2D, and that vector 2D is actually some struct. Now when you go and instantiate playerStats, that will create a sub-object, which is that location struct. Okay, that is going to be an object. So in other words, you have the playerStats object, and then that will have location as a sub-object. Now, of course, that location sub-object is not dynamic. It is just an object on the stack. Same with playerStats, that is also just an object on the stack. And when the playerStats object or instance gets destroyed, then so too will the sub-object automatically get destroyed. And that's not the case with dynamic sub-objects. The program has to make sure that that class handles the memory properly. So each time you instantiate that class, you create an object. That object has to manage the allocation and deallocation of dynamic sub-objects properly. And how will it do that? Well, you'll have pointers, and those pointers will be on the stack basically just like the object itself. But it is not the actual objects themselves. It is just a pointer to some object. So we'll have to actually go and allocate memory for the objects that we want to have be sub-objects of the class, and we'll do that in the constructor. And then also we need to make sure to deallocate that properly. And where do we do that? Well, that is where again the destructor comes in handy. Now in the next demo I'll show you something a bit more complicated where we use a playerStats and then maybe a vector 2D as well for location. But here, let's say this integer member is a pointer instead, and in the constructor, instead of initializing member to 0 here, what we do is we create a new dynamic object on the heap, an integer object, which I'll just initialize to 15 for example. With that being successful, it will return the address and store that in the member variable. It's very important to note that the object should be responsible for the allocation and deallocation of dynamic sub-objects. Before we continue, I'd like to illustrate to you using a few slides why it's important to deallocate those dynamic sub-objects again. So another memory leak example for you, we have the stack and the heap again, and then on the stack we have the main function and then also some object, entity 1 for example. Let's say our object has this int pointer, which is a pointer to an integer of course, and in the constructor we allocate a new integer on the heap, a dynamic object. So when that allocation on the heap is successful, we return and store the address in int pointer, and so at some point in the program that object will get destroyed. As we've seen in the previous section, your object gets destroyed, but now if we don't go and deallocate that object that is on the heap, pointed to by that int pointer, then of course you'll have a memory leak, because again that doesn't automatically deallocate the object on the heap now. We have to do that in the cleanup process, so manually in the destructor. We've seen similar illustrations and examples in the pointers and references lesson, but the main difference here is that of course we are now dealing with objects and object-oriented programming, and we want our objects to also handle the deallocation of those dynamic sub-objects. So again, in this case, the member is actually just a pointer. So if this member, instead of an int, let's say that was some huge object, some struct or some other class, it would be more efficient to have a pointer to that and then to allocate it dynamically on the heap in the constructor. And then when you refer to that member, that object, all you do is you pass around the pointer, this member pointer, instead of copying around the actual object, because again that can get very expensive. You are copying around the entire thing with all its member variables and so on. So it's much more efficient to copy around a pointer. Again, it doesn't matter all that much with the primitive types such as integers and floats and so on. But just as a quick example, I'm using an integer, and then in the next example, we'll do something a bit more complex. So how do we deallocate a dynamic sub-object now? Well, you might remember the delete operator. And that is basically all you do. So to go to that address in memory that is stored in member, and it will deallocate that object that is on the heap. That is just before an instance of entity is destroyed. You can build and run this and this works fine. Okay, so back in main, We are familiar with this sort of example again from the pointers lesson, but as you can see in the entity now, in the class, this now manages the allocation of dynamic subobjects and the deallocation of dynamic subobjects as well. Okay, so that's going to wrap up this first example. Take a break if you need to, rewatch this to make sure that you understand what's going on, and then I'll move on to a different example in the next subsection, which will hopefully clear this up even more for you if you are still confused. Okay, so here's another example. This example is a bit more complicated than the previous one because I'll be using two types here. So I have a vector 2D, which is a struct because basically it's just a data container, right? Then I also have a class, player stats, and then in main I instantiate player stats, so I create player1, and then from that we simply do console output get location.x again. So we've done something similar to this in previous examples. So I have these two constructors, the default constructor and an overloaded constructor as well. The default constructor simply sets x and y to 0, and then the overloaded constructor simply sets x and y equal to the parameters, so that the overloaded constructor accepts two arguments. Then we have the destructor. Now for the vector 2D, all the destructor is going to do is it's going to print out vector 2D object destroyed. Now player stats is where things can get a bit more confusing, but you'll see it's not that difficult. I have the constructor right here. All I do here is I set health to 100. That's just because we have a member variable. But you'll notice that we also have this location member variable, but in this case it's a pointer to a vector 2D. Alright, I'll scroll back up again. So in the constructor again we set health to 100, and then also we do location, which is that pointer. We set that to a new vector 2D. So we go and create an object on the heap, and we initialize it. We can go and remove these arguments if we want, but I added some random arguments in there just so we can see those print out. Okay, so the actual location member variable in this case is a pointer to a vector 2D object on the heap. And so in the destructor, what we have to do, of course, is when we destroy an object of type player stats, then we have to do some cleanup. So in the destructor, we delete whatever that location pointer is pointing at on the heap to again release that memory back to the system. And then we also print out player stats object destroyed. Again, if you can get what's going on here, then you'll be fine. We won't be using this all that much throughout the rest of the module. So set location, for example, this accepts two arguments. What we want to do is we want to use the arrow operator because location in this case again is a pointer. So use the arrow operator, and then x, we set that to the parameter, and the same for y. And then get location, all I do here is if the location is not null pointer or null or something like that, then I return what in this case? Well, I want to dereference location. Remember again, location is a pointer to some object on the heap. We have to dereference that to actually fetch the vector 2D, and that will then return a vector 2D object. Otherwise, we are simply going to return some vector 2D, which in this case will use the default constructor. Just to recap, in main, we instantiate player stats, we create an object called player1, we do console output player1.getLocation.x. Okay, let's look at what that will print out. So x is 5.4, and then we get vector 2D object destroyed, vector 2D object destroyed once more, and then player stats object destroyed. Now at this point you might be confused, why do we get vector object destroyed twice? And I'd like to leave you with an exercise. Go and rewatch the video if you have to, or look at the code, and then try and get to a conclusion on why we call this here vector object destroyed twice. Don't worry about it too much if you can do it, but spend some time and try, and even if you have to step through the code, try and see why it is that we get this destructor going off twice. Again, when we come back, I'll explain this to you. Okay, I'm back, so I'll scroll back down to main, and I'll place a breakpoint on this line here, and I'll do the local Windows debugger. Okay, what's going to happen when I step into that line is we move to this function getLocation. I'll step into that. If that location variable has some address, so it's not null or null pointer, then we are going to return this. Now what is this going to return? It is going to dereference this pointer location. What is that going to return? it is going to return a vector 2D. In the function header, we can see this returns a vector 2D. Okay, so I'll step into that line. And if I bring up the console here, you can see we still are not printing anything out. So I'll step into once more, bring up the console. You can see that that prints out now 5.4. You'll also notice that we jump to the destructor of vector2d here. So console output vector2d object destroyed. Step into that. It's going to print that out and return to the main function. Prints out vector2d object destroyed. So why does it go to the destructor on this line now? That's really weird, right? Well, remember that, again, if we go to that function, getLocation, it returns a vector2d. So right here it's going to return a vector2d. It's basically a temporary object. It doesn't have a name like x or y or something like that, but it's still an object. And that object is initialized to what information? Well, whatever is in location, or what's going to be initialized with the default values, whatever is specified in the default constructor for vector2d. In this case 0 and 0. So that still returns an object that is initialized to some value, and from that object we do .x. Again, this is not a pointer, we are not returning a pointer, we are returning an actual object right here. So all of this code right here is replaced with an object. From that object we do .x. What happens when we move to the next line? Well, that temporary object is going to get destroyed. That is why it invokes the default constructor. Okay, so moving on, I go and step into the next lines and step into that line, and eventually you'll see we move to the destructor of player stats. Remember that we instantiate player stats right here in main. So execution is right here now, and it's going to step to the next one right here, which is delete location. Location again is a pointer, and currently it's pointing to a vector2d object. So what is going to happen when we do this delete operation? Well, it's going to invoke the destructor for the vector2d object, which is on the heap again. So we step into the vector2d destructor and we print out vector2d object destroyed again. And then we move back to the calling function, which in this case is the destructor actually of player stats. And we are going to print out this line right here. And then eventually we exit out of the program. That is why vector2d object destroyed is called twice. Right after vector2d object destroyed is called, we print out player stats object destroyed as well.